Hey friends, we are in chapter 4 and we're looking at section 4.6, and today we're going to talk about functions. So rightfully so, our vocabulary starts off with the word function. And if you're wondering what a function is, I'm hoping you remember that we talked about relations a while ago. Like, so you can have pairs of numbers that are related to one another, like 2, 3, 4, 7, 5, 9. I could even put a little, I don't know, 6, 3, -2, 1. And I can have this as a set of points in a relationship. This set of points can refer to a function if and only if each of these first numbers is only mapped to one number, one and only number. So if one and only y number value, let me make this plain. So for each x, there exists exactly one y associated with it. I believe I did this with your class. I don't know if you remember, but we talked about birthdays. Remember, if you wanted to match, let's say x value was a person's name and the y value was their birthday. So for me, my name is Dion and my birthday is October 17th. All right. And I can go down the list and talk about, let's say, some kid named John and his birthday is October 15th. Then there's this other kid named Sally and her birthday is October 17th as well. And I can say that there's some other kid named Byron and his birthday is I don't know, December 18th. You've got these kids with these birthdays. Notice it is totally okay for each person to have a unique birthday to them. But it would not be okay, right? Even though that myself and Sally have the same birthday, it is cool. That's totally legitimate. But it is not okay if somewhere down here you saw that this same Dion had yet another birthday. Let's say January 10th. If that were the case, you'd know that I was doing some illegal activity because one person doesn't have two birthdays unless they've got like some falsified papers or something bad, right? I say this and I usually make this birthday point because a lot of people can get this. Yeah, one person shouldn't have two birthdays. Same thing, one X value should not have two separate Y values. It is quite okay for this y value right here, let me make this a little thicker, for this y value right here, for this 3 to be associated with 6 and to be associated with 2 as a y value, but it is not okay for us to add into this situation, let's say, 4 -1, because 4 cannot be associated with two different numbers. So the x value can only be associated with one unique y value. That's what a function is, all right? A function is a relationship where when each x value is associated with exactly one y value. I know that was long-winded, but my hope is that that will help you remember. And so now that we've got the idea of a function, we can think about functions in terms of graphs. So if I had a graph, I'm going to just put an arrow down here. If I had a graph like this, here's my XY axis, and I'm going to put some dots in to represent the points that I'm going to be representing here, right? So if I put a dot here, 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 and let's say another dot here, and another dot, let's say right here, okay? So I've got these dots. I'm going to make that a little bit more obvious. All right. So I got this guy here and this guy here. What I want you to observe is that if I have these points, they all have ordered pairs. So let's say like this is -2 and this is like -4 and this is like -5. Notice that this would be -5 some y value, let's say 2, and this is -5 some y value 1, right? I just want you to check that out. And so when I come back around, here's the vertical line test. If I can draw a vertical line, just continually draw vertical lines throughout the graph, and none of these vertical lines hits more than one point, meaning each vertical line only hits a point, then I know I have a function. Let's think about what that means. If each line I draw only hits one graph, one point on the graph, then I know I have a function. Here I created it so that it hits 2. When it hits 2, a vertical line is coming down, slicing, it's hitting two things. Notice it's going to hit an x value that has two different y values. Right here again, this x value, whatever it is, will have two different y values. So the vertical line test says, hey, if I have a graph and I want to determine whether that graph is a function or not, I'm going to just throw some vertical lines going straight down in my graph. And if any of those vertical lines hit more than 1 point, I know I don't have a function. Let me show you another quick example. So oftentimes it won't be scattered points like I drew. It might be a function like this. Or it might be a relation like this. You might see a line drawn or some kind of a wiggly graph like that. And if I draw vertical lines straight down, notice none of these lines hits the graph twice. I can therefore be confident that this is a function, that this graph represents a function. Let's do it again. So let's say I have this graph here and it looks like this. I got a nice curve that does something like this. Looks like a parabolic curve. And when I do my vertical line test, I see that almost everywhere it's hitting 2 points, at least 2 points. This is not a function, not a function. Got me? So the vertical line test, this was not a function, not a function. And this was yes, this is a function. Function. All right, so the vertical line test helps me determine whether or not I have a function by drawing lines on the graph. Got me? All right, the last vocabulary or vocabulary phrase is function notation. And so function notation is basically flipping the script a little bit. So you remember how we would have like y is equal to 2x plus 4, or y is equal to x to the third power plus 2 minus 1, or whatever nonsense. Now, instead of using y as a variable, we would use f of x in replacing y, all right? And so what this is saying is emphasizing the fact that the relationship you see here between x and y is a functional relationship, meaning for every x value, there's exactly one y value, or for each x, there's a unique f of x. All right, and we're going to talk about that, and we'll see it a little bit better in the next coming example. So let's go ahead and start taking a look at some examples now. First thing we're going to do is we're going to determine whether each relation is a function, and we're going to talk about that in reference to just looking at the mapping. So here we've got a mapping where -4 is being joined with 9, and -1 goes to -6, and 1 goes to -6, and 3 goes to 11. Is this a function? That's the question that we're asking ourselves. And the answer is yes, it is a function. Even though -1 and 1 are both going to -6, notice that -1 only goes to one value, and 1 only goes to one value, just as -4 and 3 go to exactly one value. So I like to think of it again as each of these people have one birthday, and sometimes some people have the same birthday, right? So yes, this is a function. All right, let's look at this table. So in this table, I've got -3 being associated with 6, 2 being associated with 5, so far so good, 3 being associated with 1, and 2 being associated with 4. I see trouble. This guy got 2 birthdays, right? So you see that 2 is being associated with 5, and 2 is also being associated with 4, which makes this guy not a function. All right? It's as easy as that. Let's see, now we did a mapping, we did a table, and now we're looking at a set of ordered pairs. I like to write them as ordered pairs personally, but I'm going to do the set of ordered pairs: -2 and 4, 1 and 5, 3 and 6, 5 and 8, 7 and 10. Looks good to me. I see no repeated x values, meaning no x value is being mapped to more than one y value. Yes, my friends, we have a function. All right, that's not too bad trying to determine whether you have a function or not. Not too bad at all. So over here, we're going to just have like another opportunity for us to think about the idea of the vertical line test. So here in the vertical line test, I'm going to just go ahead and run through, draw vertical lines straight down. Notice each of my vertical lines only hits the graph one time. Yes, we got a function. Over here, drawing vertical lines, notice that my vertical lines hits this graph in several places twice. Not a function. Draw vertical lines, draw vertical lines. It looks like this guy might do it, right? But this open circle means not part of the graph, and this circle means part of the graph, so it doesn't make it. It does not hit twice, and therefore we do have a function again, all right? So we see how the vertical line test can be used to help us determine if a graph represents a function. So here we have example 2, equations as function, determine whether this guy is a function. And to do that, we're going to use the skill we were just given, which is the vertical line test. So first thing, to use a vertical line test, we only use vertical line tests on graphs. So let's take a moment to graph this linear equation. And so you remember we talked about using intercepts as graphs, right? Using intercepts to graph. And intercepts, I said we're going to make somewhat of a table where we're going to put a 0 in for x and figure out what our corresponding y value is. Put a 0 in for y, figure out our corresponding x value, and we know that when we have a 0 in for x and we find the y, that is called the y-intercept. And when we do it the other way around, when we put a 0 in for y and figure out what the x is, that's called the x-intercept. And so if we get those two intersection points, we can plot those points, draw a line, we're good. We've got the graph. Then how do we determine if it's a function? We will use the vertical line test. All right, so let's go ahead and do the thing we're supposed to do. So if I do that, I'm going to deal with this part first. I'm going to take 2, multiply it by 0, subtract y, and that's equal to 6. This goes away, therefore negative y is equal to 6. Clearly y is equal to negative 6, and that is my y-intercept, right? So 0, negative 6 is 1 point, so I go to 0, negative 6, 1, 2, 3, 4, 5, and 6. That's the first point I have of this graph. My next point, I'm going to find the x-intercept, and I'm going to do that over here by taking the same equation, 2x minus 0. Notice I'm replacing y in the equation with 0. I'm going to solve for x, that'll be my x-intercept, is equal to 6. Move things around, really not really, because 2x minus 0 is just 2x. So 2x is equal to 6, divide both sides by 2, and I get that x is equal to 3. So when x is equal to 3 and y is equal to 0, 1, 2, 3, we get our x-intercept. Make sense? Hopefully it does. Hopefully you remember this from before. And then we're going to just draw a line. And this is the linear equation that is represented by this equation. This line represents this linear equation. And then so now I can go through and say, all right, vertical line test, just drawing vertical lines. And as you see, this is definitely a function. Yes, this is a function because it passed the vertical line test. All right, so we've proven that this is a function. Let's go on to our next example. So here we can talk a little bit about function notation really quickly. I told you function notation was an idea of replacing y with f of x, And so it becomes interesting because now instead of saying what is x when y is, what is y when x is negative 2, that's what this is here, right? Because remember, this would be y is equal to 2x plus 5. Right now I can just say, all right, f of negative 2 is what? Meaning, what this means is I take the equation that I have. Let me get my black pen back. I take the equation that I have, right? And I'm going to replace all the x values with the negative 2. All right? Sometimes I actually start off problems and I'll write it like this. Right? So I'll say f of blank is equal to 2 times blank plus 5. I will take away the x value and then remind myself that I need to substitute it in. You'll see what I mean in a minute. So what I did is I rewrote this equation. 2 times negative 2 plus 5 by replacing all the x's with the negative 2, and I'm going to simplify this by multiplying 2 times negative 2. I get a negative 4. Negative 4 plus 5 gives me a positive 1. F of negative 2 is equal to 1. We'll do some more examples in the next part of this video.